So today we'll be talking about preload and its effects. So we know that preload is basically the stress on the wall. So we have our left ventricle and it's the stress on the wall, And what this causes is that when we have more preload, we have more pressure. We have more pressure. And what happens in pressure? You have more and the preload is the stress, right? It's stretching, stretching. So we have a cell here, a heart cell. So if we saw this heart cell bam, over here, it's very happy. And then it would be stretched over there and over there. So it would be something like this. It would be stretched. And so, or actually, it would be something like would be like this, here and here, something like that. Okay, and then what would happen is that we have our cell here, our actin, actually our myosin, our myosin, okay, and then we have these heads, myosin heads. So we would have a bunch of them. I'm only going to draw 3, but you kind of guess it. There is more, right? Here. Let's draw 3. Let's draw 3. Okay, so then we're gonna do the same thing over here. Okay, and these myosin heads they have polarity, so they can only attach to a certain place of the myosin. So what happens when it's not stretched? There is an interference, and they can't really use these two myosins over here. So it's bad. But when it's stretched, it's the same thing over here. When we stretch them, it does something like this over here, over here. So every single myosin is being used. So that's very good. And also another thing that happens is that the iotic mechanism. This is Franklin-Starling mechanism. And the other mechanism is that we have our myosin over here that is going to bind with our actin, right? But what doesn't let it bind is the troponin, which is preventing it from binding, right? So we need the tropomyosin to let it to break this and let the myosin bind, right? So the troponin wants to bind, right? I mean, it's going to help, but then the calcium uh, uh, wants to bind way more, so they are going to have more energy with the calcium, because the calcium is kind of woken up because of this. And so it's better to have more pressure, and with more myosin attached, there is more pressure on the systolic. So we saw the end diastolic, and now here the systolic. So yeah, it helps a lot to stretch a little bit, not too much, but